the difference?
So indefinite doesn't have an exact set of points.
Okay, so it sounds like you're focusing on these guys over here, the A and the B. The fancy word for these are?
Endpoint.
They are endpoints, but really I was hoping for limits of integration. Limits of integration over here, no limits of integration over here. That's visually what you see. What's the big difference? What's the question that you ask over here versus what's the question that you ask over here? I see David, I see Marvin, I see Jasmine. Jasmine, what's the difference?
The one on the right is what function has f of x as the derivative.
The question over here is what function do I know of that has the little guy f of x as the derivative? Christian, what's the big question over here?
What's the area bounded by the 4?
Good. What's the area bounded by the function, the x-axis from x equals a to x equals b? On the left, we're asking an area question. I know you guys have seen me draw this like forever, right? Your answer is usually going to be a number. On this side, your answer is going to be some function, but it's going to be a function plus c. Let's not forget Charlie. Right, c is that constant of integration. It could be any constant in the beginning, and eventually we start whittling it down. Everybody okay? All right, see 3, 6, 10, 13, 17, 20 good-looking people. Who don't I see? Kimberly, and she told me about that. Okay, so yesterday we were just doing a lot of like, what do you think the antiderivative is? Today, for those of you that like to memorize things, for those of you that don't trust your instincts, I just got a whole bunch of formulas to share with you. All right, so let me get the lifesavers here. Looking at these top 11, does anybody know any of them by sight? Any of those top 11, you see it and you know exactly what the answer is already. Nora, give me one of them.
Number 3, the square root of x.
Okay, number 3. The question here is what is the indefinite integral of 1 over 2 square roots of x? What I'm really saying is what function do I know of that has this as its derivative? And your answer is? Square root of x. Like it, don't love it. Like it, don't love it. Eunice, why don't I love it?
Plus c.
Plus c, plus Charlie. Nora, nice job. Any other ones? I'll take anything from anybody. Edgar?
Number 5.
Number 5. The antiderivative of sine of x is?
Negative cosine of x.
Oh, God bless. I was afraid
Plus
you were
c.
going to say the other thing.
Plus c.
Negative cosine of x plus Charlie. Abraham, give me another one. Number 6. What's the antiderivative of cosine of x?
Negative sine of x.
I'm sorry, what was that?
Negative sine.
The antiderivative. The question is what function has cosine as the derivative? So the answer is positive sine of x. In the business, we call that the wait time. Sine of x plus Charlie. Rambier.
Number 7 is e to the x.
Right, what has e to the x as its derivative, everybody? E to the x. Don't stop there, though. E to the x plus Charlie. Rambier. There you go. Noemi, give me another one.
Number 2,
Number 2, what is the antiderivative of 1 over x?
natural log of x plus c.
Natural log of x plus c. Now, for all the folks watching this at home, you're like, wait, he's wrong. Yes, I'm wrong. It is actually natural log of the absolute value of x plus c. The reason for the absolute value bars is the natural log has a domain restriction. The graph of the natural log, you guys should all remember exactly what that looks like. It's a parent function. We played around with it before. Sketch it in the air, please. The natural log of x. Natural log of x. Natural log of x looks like that guy there. The natural log of x is defined only if x is greater than 0. That's your domain, right? All the x is greater than 0. Over here, there's no restriction. X could be anything. So the antiderivative of 1 over x is natural log the absolute value of x plus c. How picky am I going to be about this?
Very.
Very picky. Very picky. Just because, you know, you guys are getting good at stuff. I got to pick other fights. All right, other ones. Other ones. Eunice.
Number 4.
Number 4. What is the antiderivative of negative 1 over x squared?
1 over x plus c.
1 over x plus c. Well done. Now, you might even want to put a little note down here because what's going to start happening is I'm going to ask you what's the antiderivative of 1 over x squared? Somebody back there get that. Antiderivative of 1 over x squared. If the antiderivative of negative 1 over x squared is 1 over x, the antiderivative of 1 over x squared has to be?
1 over x.
Oh, so awkward. If the derivative of 1 over x is negative 1 over x squared, what would have 1 over x squared as the derivative? Negative. Right? It's just the negative 1 over x plus c. All right. Any other ones? Other ones? Jasmine.
Number 8.
Number 8. The antiderivative of e to the negative x, you're going to tell me is?
Negative e to the negative.
Negative e to the negative x plus c. Great. Love it. 4 more.
Get out of there.
David.
Number 1.
Number 1.
1/2 x to the n squared.
1/2 x to the n squared. Good try, no.
Oh, plus.
Imagine that n is some number like, it's not actually this, but x cubed. I know a lot of you guys figured this out yesterday.
Oh.
The antiderivative of x cubed, Edgar, would be what?
Wait, what?
The antiderivative of x cubed. What function has x cubed as its derivative? And you would say?
1/4
1/3.
times
1/3
x to the 4th.
1/3 x.
If
1/4
this
to the
is
fourth.
the derivative, the function it started with must have had an exponent that was 1 bigger. Had to be x to the 4th. But when I bring that 4 down, I'm supposed to multiply by something and get 1. So what has to be here? 1/4. So the answer would be 1/4 x to the 4th plus Charlie. Yes, ma'am.
So the other one would be 1 n x to the n plus 1 plus 1.
Okay, normally I focus on the exponent first. I think the exponent has to be 1 bigger than what I have over here. And then what do I have to do?
1 over n.
1 over
n plus 1.
1 over n plus 1, because I'm dividing by that new exponent. Add 1 to the exponent, divide by the new exponent, plus
Plus
Charlie. And for right now, we're just going to put a little note that n cannot be equal to -1. We'll talk more about that later, but time is ticking. All right, so nobody? No, no, that?
Yes.
No, just tell me.
IDK plus c.
ITK plus C, no. No. So maybe we go for an easier one here. If it was e to the 2x, what function would have e to the 2x as the derivative is the right question.
Oh.
Nora, what are your thoughts here?
1 over 2x plus 1.
1 over 2. I agree with you with the 1 over 2. How does the exponential work? If I take the derivative of e to a power, right? Can you maybe? If I'm going to take the derivative of e to a power, the chain rule says e to the same power times the derivative of the power. So it's 1/2 e to the 2x plus Charlie. Right, that's like a specific case. If k is equal to 2, then it's 1 over 2 e to the 2x. If I had made this e to the 5x, everybody would tell me? Oh God. If this was e to the 5x, everyone would be able to tell me that the antiderivative is 1/5 e to the 5x.
Plus
So over here, if it's e to the kx,
1 over
it's 1 over k e to the kx plus Charlie. The antiderivative of sine of stuff, we've already established is negative cosine of the stuff plus Charlie. And there's going to have to be a -1 over k in front. Again, chain rule stuff that we're trying to undo here. The antiderivative of cosine kx has to be sine kx plus Charlie with the little 1 over k in front. All right, these last two really, this is for the folks that are hungry for a 5 on the AP exam. Last year, not even 6, just 5. Last year, maybe it was 2 years ago, this was the last question on the multiple choice part of the test. And, oh God, I got to see some of the work that students were trying to do, and they just went all over the place. If only they remembered their derivative rules or had their derivative foldable. Of course, that would be cheating. We wouldn't do that. Okay. Does anybody know of a function that has secant of x times tangent of x as the derivative? Offer up a B's point for this. Either you know it or can find it in the next 5. 4, 3, 2. Jennifer? I'm sorry, what was that? Secant what? Secant of x plus Charlie. Well done, I owe you a B's point. The antiderivative of secant of x times tangent of x, I've already established that, is going to be secant of x plus Charlie. Done. And antiderivative of secant squared. Does anybody know or can find the function? Marvin, I've ignored you for a little bit. What function has secant squared of x as its derivative? Tangent of x plus Charlie. God, could not have said it better myself. I've already established that.
Wait.
Do I get paid?
Isn't it, wouldn't it be negative 10 since it's positive secant?
Nope. Nope. Derivative of tangent is secant squared. So I will tell you right now, my flashcard people, these are things worth turning into a flashcard. If all goes well on Friday, we'll do a little like integration foldable so you can play around with that. Jose, you all right? Don't hit your head against the desk. Let me do that. So here's what I want you to do. I want to. These should be quick like a bunny. Now that you've got those integration formulas done, I want you to get some practice with the basics. You should be able to do problems 1, 2, 3, and 4 in 4 minutes or less. When you think you've got it, call me over. I'll give you a high five and I'll move you on. J-O. Not to be confused with J-Lo. Oh, you'll take it. No, don't worry. And Marvin, I owe you a B's point. Is that right?
It would be 112. 2 to the 12. T, it could be any number. No, it's T squared. No.
All right.
But then it would be 2
Love. No.
1/2 T squared.
Like it, don't love it. Like it, don't love it. You got some work to do over there, Marvin.
Yeah.
Yeah, 1/2. This should be true.
Yes, sir. Love. Keep going. All right, so I've seen on a whole lot of papers. Number 1, we've got x to the 4th minus x squared plus 7x plus Charlie. How many guys honestly have the first one right? Good. Good. Also seen a lot of papers. This next one, antiderivative of sine of x plus cosine of x. Addition and subtraction is good for us. Antiderivative of sine of x, everyone's going to say is? Negative cosine of x plus antiderivative cosine of x. Sine of x plus Charlie. Love. This one over here is going to trick people up. It's just going to happen. Jose, jump out there. What do you know?
1/12 t.
1/12. Tell me, how did you get that 1/12 t to the 12th? What did you do?
Bring the power down.
No, you didn't.
X.
Not with the antiderivative. I started with t to the 11. How did you get to t to the 12th?
Add 1.
You power up.
Power up.
Right, we're going to add 1 to the power, and then
1 over that number.
1 over that. We're going to divide by the new power. Add 1 to the power, divide by the new power. Nice. Next one, the antiderivative of t to the 8th. 1 over 9, t to the 9. Minus, this one's always going to mess with you.
1/2 t squared.
Right? Because you guys are good with your exponent rules. You know that there's a hidden 1 up there, so minus 1/2 t squared plus, I saw on 6 different papers, the wrong answer for this next part. The most popular wrong answer out there right now is square root of 7x.
Oh, t.
Edgar, why t?
Because we're solving for t, not x.
Well, we're not solving for t. T is your variable of integration. Okay, square root of 7 times t. Don't forget Charlie. And the last one, antiderivative of e to the x is?
E to the
E to
X.
the x.
E to the x. Antiderivative e to the negative x.
Negative e.
Negative e to the negative x. Don't forget Charlie. Love. How many guys get all 4? 3 out of 4. I can take 3 out of 4. All right. Good. Keep going. We're going to up the game a little bit. 3 more minutes.
Oh, no. Natural log, absolute value of c. That's it. One over x. Oh, yeah.
Oh, no.
Minus 1 over x. Oh, no, wait. Yeah, 1 over x.
So sad. Oh, so sad.
And then it was just 1 over x.
Oh, so sad.
Yeah.
I just saw that on somebody's paper. It made me sad for so many reasons.
What do you write?
Z.
Oh my God, so many things. No, I mean, what's one of the things I don't like here?
The variable is c.
The variable is z. Mark's here, don't worry. I'm not going to let anybody know it's on your paper. Okay? Like that better. Another problem. Another problem. Oh, picky pants here. Adriana, what's the problem?
The natural should be of the absolute power of
Natural log of the absolute value of... Okay, I know. Move on. Move on. It's not all about you, okay? It's all about...
Oh, I forgot how to do it. Don't we have to split it up? Like, do the little definite interval? Yeah. No.
Wait.
Hey. I don't know.
Okay, forget about the 6 for a second. What's the antiderivative of 1 over t? No, what you have is unnatural. It's natural log of the absolute value of t. It's natural log and then the stuff on the so it's 6 times the natural log of that.
Or natural,
And then
natural log of 6.
minus pi. What has 1 over t squared as its derivative? What has 1 over t squared as its derivative? There.
Wait, no. Because normally it's 1 over x.
Okay, good. Now you can stay.
But isn't it still? Because 1 is a number and then x.
Good. Keep going.
Yeah, so like the 1 goes outside, I guess.
Oh, yeah, 6 natural log of x. Or of t.
Uh-oh. Red alert. Nope.
No.
Is it plus?
What do you mean?
I mean, hey, no.
Wait, what?
What is that?
Plus? Oh, okay, so it'll be plus.
Because negative, right now it's t to the negative 1.
I think it's like,
6 natural.
I think it is. Wait, but why are you taking the 6?
because, you know, like Christian said, it's an imaginary one.
Instead of the
Yeah. So it's like 1 natural log. So that, like, that's the imaginary one. That's
All right, friends, let's pull this together. There, 3 out of the 4 should be relatively quick and easy. This first one we've already established. Square root of z plus the natural log of the absolute value of z plus Charlie. How many guys honestly had this one right before I picked on Martyr, and everyone needs to know he had the absolute value bars there. Okay, number 6. Number 6. Number 6. Number 6. Jonathan, what you got for me?
Natural log of the absolute value of x
Natural log of the absolute value of x
plus 1 over x.
plus 1 over x dx. If you're not sure, here's a legal thing. Break this up and say I need the antiderivative of 1 over x dx minus I need the antiderivative of 1 over x squared dx. Is it legal to break up an integral into 2 separate ones?
Of course.
Sure, in addition and subtraction, but never multiplication or division. 1 over x, hey, that's one of the ones I have memorized or will have memorized by Monday on the quiz. Natural log of the absolute value of x minus the antiderivative of 1 over x squared would be minus negative 1 over x or positive 1 over x. Jennifer?
Why do you have D?
Yeah, I was wondering. Isn't it why didn't you
On the
just
front,
plus
on
C?
top.
Yeah.
Plus C.
These point.
Shut up! These point for anyone who keeps them quiet for the next 8 minutes.
They're not getting that.
Yes, they will. Marvin will do whatever it takes. Thank you for making me a better teacher. Thank you very much. All right, I would also hope number 8, relatively quick and easy. Relatively quick and easy. What's the antiderivative of 2 sine of x?
Negative plus
2 times the negative.
Now, some of you might say it's 2 times negative cosine of x. I heard Nora and some other folks say, but I'm probably not ever going to write it this way. Instead of 2 times negative cosine of x, the better way to write this is negative 2 cosine of x. Now I need the antiderivative of sine 2x.
Negative 1/2.
Right, think about this, like this is now like that kx example where k is equal to 2. Antiderivative of sine 2x, negative 1/2 cosine 2x plus Charlie. This one I'll just tell you guys what the answer is. We're not going to spend much time talking about it because we only have 8 minutes left.
6 and 12.
The antiderivative of 6 over t, well imagine for a second if it was 1 over t.
Natural log.
You guys would say natural log absolute value of t. Well, if I have 6 times that, it's going to be 6 times the natural log of t. And I can tell Noemi to get that right. Let's do the same thing with the pi. We're going to be sort of flexible with our constants here. The antiderivative of negative 1 over t squared. What's the thing that has negative 1 over t squared as its derivative?
1 over t.
1 over t. Well, I need pi times that. So this is going to be plus pi over t plus Charlie. Tonight's homework, there are going to be a lot that are just quick recognition. You've memorized it. You've got your integration formula. On Friday, we'll have the foldable. What I want to do is push you guys just a little bit more. Just because I don't get the pleasure of pushing you guys tomorrow. There's only 3 problems that we're going to look at. I want to look at 1, 2, and 4 and see where we can go with this. These last ones that you guys did were relatively quick and easy because they all fit a pattern, right? They all fit some integration rule that I know we're still babes in the woods. But if I look at my integration rules, if I look at my derivative rules, I don't necessarily have anything that gets me 1 over the square root of x. But sometimes clever algebra is the way to go. I want to do some clever algebra here in the integrand. So let's make sure this is legal. Rather than saying square root of x, I'm going to call this 1 over x to the half. Legal? Right? Legal because square root of x just means x to the 1/2. Okay. Instead of the cubed root of x, another way I can rewrite this is going to be x to the 1/3 dx. If I want to go even a little bit further with my algebra rules, not calculus stuff, 1 over x to the half, another way to rewrite this is going to be x
negative 1.
X to the negative 1/2 plus x to the 1/3. For those of you that are sometimes a little bit sloppy with the notation, all I'm doing right now is rewriting the integrand. I'm not doing the calculus. I haven't found an antiderivative yet. Now, x to the negative a half doesn't, it's not in that table that we're gonna have to get memorized, but it is in one of the forms. Specifically, this has the form of x to the n power. Right, if this was x to the fourth, you guys wouldn't even stop and think. You'd say, oh, the antiderivative of x to the fourth, what am I supposed to do? Add 1 to the power,
Make it over and over.
and then divide by the new power, right? If this is x to the power, does everybody see this is x to a power?
Yes.
Then, to find the antiderivative, add 1 to the power. This is going to be my favorite part of the game. Add 1.
Positive 1.
Oh, I love this part of 12th grade. Add 1. Negative a half plus 1. Jonathan apparently loves this game as well. If you're not sure, write it out. Negative a half plus 1, do a little side work.
25. Negative 25.
Okay, and we're going to avoid the decimals. Okay, negative a half plus 1 is the same as negative a half plus 2 halves, so that's 1 half. Then, if that's your new exponent, divide by the new exponent. Love it. 1 over a half. We'll come. You might even know it's 2. But let's come back. Plus, now I need to find the antiderivative of x to the 1/3 power. Well, x to the 1/3, that's still x to the n. But now n's going to be 1/3. Add 1 to the power. So I've got 1/3 plus 1. Let me go up here. Okay, 1/3 plus 1 is 1/3 plus 3/3, 4/3. I've got x to the 4/3. So that's really 1 over 4/3 times x to the 4/3. Add 1 to the power, divide by the new power. And then plus Charlie. And the just right question that I'm sure somebody wants to ask right now. Can we leave it like this?
Yes.
And the answer is? The answer is, it depends. It depends. Free response portion of the test, David, what are you going to do?
Leave it as it is.
Right, this is great. You're like, done if it's free response. If this is the multiple choice part of the test, I will never, ever leave it. Because I have high expectations. If that translates into evil, I'll take it. Okay, so how am I going to hide this from you? Let's get some hands on this. What can I do? What could I do? This is no longer a calculus question. This is like an algebra 1 question. What could I do to hide this from you? Edgar sees something, Jennifer sees something, Adriana sees something, girl in the front here, Nora sees something. Edgar, what do you see?
Wouldn't you just flip the bottom in the denominator?
Flip my bottom. I'm not. So 1 divided by a half is really the same thing as 2. Good. So 2x to the 1/2. Please don't think about my flipping my bottom. 1 divided by 4/3 is 3 over 4. 3 over 4 x to the 4/3 plus Charlie. Love. Maybe that's the answer. But I could do more. Eunice, what else could I do to hide this from you? Okay, instead of x to the 1/2, hey, let's call it 2 times the square root of x. Instead of x to the 4/3, you know what I'm going to do here? X to the 4/3. The denominator says take the cubed root. The numerator says raise it to that power. Either of these would be great on the multiple choice. On tonight's homework, I really want to encourage you guys to go all the way. Simplify as much as you can so that you're getting practice for the multiple choice. But if it's free response, stop. Okay? Hi. Jonathan, you all right there? Jonathan, you look sleepy. That can't be right. All right, one more. Ooh, yeah. Oh, let's look at number 4. Oh, let's look at number 4, because this one's going to be a bloodbath. Bloodbath, and I will not be here tomorrow to put Band-Aids on you. Antiderivative of x times the square root of x plus the 5th root of x squared. Ugly stuff here. Let's go real quick, real quick. Rather than saying x times the square root of x, smart money says, how about make this x times x to the half? Plus this guy over here is going to be x to the 2/5. Multiplication is bad news for us. Multiplication is always bad news. So do some legal algebra here. X times x to the half, the legal thing, I can add those exponents. And so I'm going to call this now x to the first times x to the half. That's really x to the 3/2 plus x to the 2/5. Now add your power. So it's x to the 3/2 plus 1 is 5/2. 1 divided by 5/2. X to the 7/5. 1 divided by 7/5 plus Charlie, and we'll pretend it's the multi-free response and we'll stop there.
Where did you?
Tonight's homework, round 1 on the last page. These should be quick and easy. In round 2, I want you to pick 4. Any 4, it doesn't matter to me. Those last 4, you're going to have to play around with them a little bit.